Join me, Harriet Gould, for the Lab Matters podcast to hear fascinating stories every week from the inspiring people behind the science. In this episode of Lab Matters with me, Harriet Gould, Richard Peace gives us a glimpse into the world of manufacturing through the lens of a scientist. Today I have with me Richard Peace, who is a Durham graduate and has spent a little bit of time at Cambridge University as well. And Richard is the director for R&D at a company called Generation Phoenix, which is an interesting one. We're going to come on to that, recycling leather for various different uses. So Richard, thank you for being with us today. And
thank you for the invitation.
Great pleasure. So let's go back to Durham, but actually miles before Durham. What give us a picture of what led you to Durham in the first place.
Well, miles before that, I think it was always clear I was going to be a scientist. I feel
What do you
sorry
think
for my.
what do you think made it clear?
I was always interested in science, and particularly biology and animals in my younger time. I feel sorry for my mother because she was a French teacher and she was, I think, a natural linguist, and she had two sons who turned out to be very scientific, not linguistic at all. But the biology thing is an interesting one. For years, probably from the age of 8, 10, I was interested in biology and animals, and I was very inspired by David Attenborough at the time, but also Gerald Durrell, who was, they were on television at the time, quite inspiring. And right up to A levels, I think I was convinced I was going to be a biologist or a zoologist, and I was going to do research in that, not really knowing what research even was at that point. And really, it was during my A levels I had a real switch, and it happened within the first term. I was lucky I'd started doing 4 A levels, so I was doing maths, physics, chemistry, biology, thinking I was going to go on and really focus on the biology. And actually, within a term, I was bored of it. Um, it was There was a lot of learning of facts, and it's just you learn this is what happens and that happens. And at the same time, chemistry became a lot more interesting. And chemistry at GCSE had been very much you just learn things. And I think at A level, it became, particularly the organic synthesis, it's more, this is a toolkit you can use to do things. And
Mm.
that really started to fascinate me. And I think there was always also a bit of an element of you're influenced very much by your teacher, aren't you? And a good teacher can make a big difference. And
Who was
I
the
don't
teacher in
think
this
my
case?
bio, sorry?
Who was the teacher in this case?
Well, in this case, my chemistry teacher was my father, and my biology teacher I don't think was a great teacher. And I didn't become a chemist because my dad was a teacher, but he was a great teacher, and he made it interesting. And one, I think my favourite example was he used to do an experiment where you take sulfur, you melt it, you pour it into water, and it becomes plastic sulfur. Um, and I think the experiment is written, you then apply some mechanical force, and that changes the allotrope back to the yellow sulfur. What he used to do is he used to put it in his mouth and chew it, and he used to spit it out along with his false tooth. Which
Wow.
breaks all of the health and safety sort of regulations. But years later, I was reading New Scientist, reading the letters page, and there's a letter from somebody about their chemistry teacher who used to do this experiment where they chewed sulfur and spat out their false tooth. Now I'm convinced there was only one teacher in the company in the country who was doing that particular experiment. But I think it was that was the point I became a lot more interested in chemistry, because I think I could start to see how you might use chemistry.
Mhm.
And yeah, from then on I went and did a chemistry degree at Durham.
You didn't have any qualms about switching from biology to chemistry. It was quite I'm bored of this
Not
now.
at
That's
all.
more interesting.
No, it was very interesting. It was very clear to me,
Mm.
this is more interesting, to the point where I actually dropped the biology A level after probably 1 or 2 terms. It was very,
Mm.
very quick switch.
So
I
did
can't
you?
say I've regretted it.
No, no, indeed not. Did you get any? Did you get extra help from your dad when you were doing chemistry, or
No, not
was
at all.
he was he was a teacher at the college rather than
He was a
yeah.
teacher at the school,
Mm.
and he had, I believe, when I was doing GCSEs, he had deliberately created the timetable so we didn't cross at all. So he tried to make sure, we didn't actually come across each other, but at A level, he did a lot of the A level teaching. Um,
Mm.
I was actually taught some of the time by his chemistry teacher from A level,
Oh, how funny.
because he'd gone back to teach at the local school where he'd brought up. So
Mm.
yeah, I was taught chemistry by his chemistry teacher, who was, fascinating man, really old school
What was his name?
chemistry teacher, Mr. Hawksworth.
Mr. Hawksworth.
Mr. Hawksworth, and
And
it was a beautiful old chemistry lab as well. It was teak benches and teak fume hood at the back, and I can still remember the smell of the kit separators at the back that would produce hydrogen sulfide. I think, and actually when he retired from teaching, it coincided with them stripping out the chemistry lab and refurbishing it, and they made him a set of bookshelves out of the old teak bench from the front. So yeah, in their house they've still got a teak bookshelf made from the chemistry lab.
nice, nice repurposing. Shame
Yeah,
they couldn't have kept the old one. I suppose we have to upgrade everything at some point.
you have to, and it was probably impregnated with all sorts of nasty chemicals you weren't allowed to use at the time. He's got some interesting stories as well of changes in health and safety. They had things in the school lab that, we wouldn't even use in an industrial lab anymore. And so he gradually had to go through the store cupboard, you know, removing the benzene and the carbon tetrachloride and safely disposing of them.
Yeah. It's extraordinary, isn't it?
Mm.
I think,
Huge changes when you think of what has happened between, my dad learning chemistry at university and having to learn German because that was the language of science and chemistry at the time, through
mm,
to where we are now. So somebody said to me a few years ago the international language of science isn't English, it's broken English, because you've got so many people across the world speaking, talking about science in English. But going back right then, it would have been, it would have been German.
mm.
Huge shift.
Do you know when we adopted a more productive position in the world of science?
Don't actually know.
Hmm. Be one to
No.
look up. We'll look that up later.
It's an interesting that shift. Obviously, Germany was always very strong in the chemical industry and
Hmm.
still is. I mean, I've probably spent more time in Germany than any other foreign country, mainly for work. I think I'm planning to go on holiday to Germany this year because I've been to Germany so many times, but I've never been there on holiday really, and it feels like a gap.
Hmm. Hmm. So anyway, back to Durham. You decided on your chemistry degree. You went to Durham. You
Yes,
had presumably very good tutors there as well.
yes. Yeah, a lot of time, in the lab practically. Summer of the second year, actually, I worked in one of the research labs over the summer doing a bit of polymer synthesis, and that was probably the thing that convinced me that yes, going on and doing a PhD was what I wanted to do. I enjoyed that
Hmm.
synthetic chemistry, the novel side of it, creating something new. That was really interesting, and using the science you've learned to, again, it's coming back. Chemistry is, certainly at the organic synthesis side or inorganic synthesis side. It's a bit of a toolkit. You can go and make new stuff with it, and I think that's exciting.
Hmm. Did you have any idea at that time of the sort of thing that you wanted to make?
Um, Going back to A levels, I really like d orbitals. It sounds silly, but I just like the shape.
Say that again, the
D orbitals, just the
d
shape of the
orbitals,
molecular,
right?
you know, those atomic orbitals and molecular orbitals are really, and again, I think there was a bit of you could understand what was happening and why things were bonding together, and then that comes through into what the properties of them are. But I think there was just an aesthetic thing about, you know, that they're one of the more interesting shaped orbitals. So I liked that at A level. I always liked the inorganic chemistry throughout the degree. I think it was the sort of area I was strongest in, probably because I was most interested in it. And I went on to do a PhD in organometallic chemistry,
Mm.
um, mainly because I like the shape of the d orbitals, I have to.
Never mind the application or what.
Yeah, there was, and you sometimes make these choices, don't you? And you don't know at the time you make a choice, you don't know the impact of the decision you're making, and it can be made for a very good reason, or it can be, I like the shape of a d orbital.
A little bit like betting on the horse because you like its name.
Yes, and
Well,
sometimes it works, doesn't it?
yeah, it does. Sometimes it does work. So tell me about what took you from Durham to Cambridge.
Um, so I finished my PhD at Durham, and at the time, sort of mid 90s, I think the chemical industry in the UK was in turmoil. I would have gone into an industrial job at that point. I think I'd enjoyed the PhD, but maybe a little bit frustrated that it was very it was quite pure academic research. It was, you know, it was fun making the molecules, but there wasn't a direct use for them. And I think I wanted to do more applied use of the chemistry. But very few jobs around at the time. So I went on and did a postdoc at Durham. This time in controlled polymer synthesis. So using the same techniques I would have done for the inorganic, a lot of inert atmosphere, vacuum line work, but making polymers instead of inorganic molecules. Um, and that was interesting. There was an application for it. It was sponsored by DERA, as they were known at the time, who became Kinetic. But that was around light emitting polymers, and yeah, that research leads through to, you know, a lot of the screens we spend a lot of our lives now looking at these very thin screen display technologies. So it was interesting to me because there was an application at the end, but actually that was the point at which I switched into being a polymer scientist. And I don't quite know how to describe myself now because what I do is so diverse, but I think for a lot of my career, I would have probably described myself as a polymer scientist. And without knowing it at that point, that decision to do that particular piece of work has defined 30 years of my career, essentially.
Hmm.
Uh, and then that came to an end, and yeah, still really looking for an industrial job, but needing something and looking to relocate. I moved down to Cambridge to do more of the sort of controlled polymer synthesis. Um, and I was there for 18 months before I found an industrial role. But that's really what brought me down into this area where I still am now. And you know, I think of Cambridge as a home now. I've been here for, you know, for so long.
Hmm. Hmm. So I want to I want to give a good amount of time to the what you're doing now, because it is quite interesting and it doesn't necessarily seem obvious, an obvious segue from being a polymer chemist. And because you're recycling leather. And
Yeah.
first of all, I mean, you've obviously had a few jobs in between then and now, but how did you come across this company and what Generation Phoenix or Gen Phoenix? What shall I be calling it?
Uh, we
Gen?
tend to use Gen Phoenix because it's less of a mouthful and it sounds a bit cooler. So I mean, how I ended up here is, and I won't go through the very zigzaggy path I took in between, but again,
It was a zigzag.
it was a very zigzaggy path because I went on from the postdoc. I did some 3D printing. I ended up at a tape company, which was it was in some ways it was quite a boring job, but in a way it was eye-opening, and that it was my first job working in a manufacturing plant day to day. And up to then, I think I'd been into a factory 3 times in my life,
And when you say tape, you mean
Adhesive tape.
sticky
So this
tape or
word,
yeah,
um,
not cassette tapes.
it was no, so it was adhesive tapes for industrial assembly, but also the bit I spent a lot of time on was medical wound dressing. So a wound dressing of plaster is essentially a different shaped piece of self-adhesive tape. And I think what's again, it's one of these decisions you make and don't know the impact. I started working on large coating lines, roll to roll processes, and almost everything I have done since that point, I think it's about 23 years, has been on roll to roll processing of materials, a lot of which were polymers. So again, there's a decision you know, you don't really make a decision. You're looking for a job and somebody phones you up, and it was an odd one. There's a job relocating a factory from Wales into Dunstable. Do you want to run that project? And I'm thinking, I haven't got a clue how a factory even works. I don't know where I'd start there, but it sounds fun. So let's go for it. And sometimes you make these bold decisions, and I think you just have to go for it. And well, this might be a disaster, you know, and I'll have to go and find something else. Or actually, this might be something really, really interesting and cool. And yeah, the job quite quickly became repetitive and was boring. But the 18 months I spent there, I learned an awful lot about roll to roll processing. And I was lucky that my boss there, a guy called Terry Coates, had been in the industry for a long time, but spent the time with me early on, walking down coating lines. You know, the blade is shaped this way for that reason. The stenter rails here, and they do that, and the oven works like this, and I still use a lot of that knowledge that came out of that time. But
Mm,
then that flows through, and I went through a number of, you know, different roles, almost a process support, product development, far more innovation roles. But again, it's mainly role to role processing, and that comes into what we do at Gen Phoenix, which is recycling of leather, but it's all role to role processing, and that's where a lot of the efficiencies of the process come in.
mm. So tell me about how the late founder came up with this, Chris Bevan.
Yeah, it's
Yeah.
it's um it's a really it's an interesting story, and I think we can learn a lot from how Chris approached it. So yeah, unfortunately, I've never had the opportunity to meet Chris, but um, very early on in the development, he brought somebody else in, a lady called Jane Wang, and she still works with us, and she loves to tell stories about Chris, and everybody who talks about Chris, I've not heard a single negative thing about him. So he does sound like an incredible guy, and if you look at his legacy and the factory I'm sitting in now, you know, it's a fantastic story. But really, it starts in 1994, and I know this because I've got all his old development files on a shelf. 1994, he's seen these masses of waste that is produced by the leather industry, and says, "Got to do something with this. This, you know, it's going to landfill or it's being incinerated. We need to do something useful with it." And I don't think at that point he doesn't know what he wants to produce. He just wants to solve this waste problem. Um, and Chris and then eventually Jane go through all sorts of processes about how do we take this leather waste and turn it into something, and they eventually come up with a process of milling it down into a leather fiber. So the structure of leather in a hide is it's a fibrous material, and that fiber itself is a beautiful, strong, supple, useful fiber. So they break it down into the fiber, and then they reconstitute it and tangle it back together using high pressure water. So all of these processes are known in various industries, but they work with a huge number of partners to bring all these processes together and use them in a way that has never been used before to create a unique material.
Mm,
Um, and one of the stories that Jane tells, which is I think it's sort of it tells you something about an invention process, and this often happens, that it's almost an accident. They've entangled this leather and they've got a beautiful sheet, but it doesn't have the strength to it, so it can't be used for something. And Jane looks up and she sees the net curtains in the room, and it sparks her to think, well, if we incorporate a textile in here, we'll get the strength of the textile. And that has become the basis of what we do. We entangle leather fiber around a textile core to produce a composite material.
Hmm. And just going back a bit, I mean, you might not know the answer to this, but what made Chris specifically notice the enormous amount of waste leather? Because
I,
I mean, there's a lot of waste everything everywhere
yeah,
now. Why specifically leather?
I don't honestly know. It's a good question, but no, and he'd done plenty of other things. I think he was a natural inventor.
Yeah.
And a lot of this work was Chris working from his garage.
Hmm. Okay. So we've
And
got,
they worked with and it's interesting, the last year or so, we've been reaching out to universities and research institutes, and so many of them have said, "Oh, we worked with you years ago. I used to work with this guy called Chris Bevan," and so he had his fingers all over the place. He was clearly a very good networker and good at putting things together. Um, and it was that period. It was 2006 that the first factory was built in Peterborough and put together. So there's sort of a 12-year period there where they're traveling around Europe doing a bit of the process here and a bit of the process there, and storing it all in Chris's garage, I think.
hmm. And you've got two manufacturing sites in Peterborough now, is that right?
We do, yes. So both in Peterborough, we've got the older facility that we still use for some manufacturing, and a newer, much bigger factory, the other side of Peterborough, essentially doing the same thing, but the newer factory has taken a lot of the early learnings from, the factory was built in 2006, but there's still a lot to learn about the process. The newer factory takes a lot of those learnings into account, and is bigger and faster and more automated. And what struck me when I first came here is that I've never seen a new, in all the industries I'd worked in, I was in old factories, and this is a brand new factory in Peterborough, completely new equipment, um, doing something actually a little bit crazy, and really, really quite groundbreaking.
Hmm. So you joined in 2019?
I joined 2019, so the new factory was the commissioning had just started, and yes, I joined just before COVID struck. Which was an interesting time to join an aviation business.
And
I
that's,
joined.
we've just dropped that in there because it didn't sound like an aviation business initially. It sounded
No, so
like
so
a
so I guess
textile
we
business.
missed that bit. So
Yeah.
so the journey between Chris doing that work and me joining was really commercializing it and finding an application for it. So the leather textile that Chris designed can be used as a replacement for a traditional leather. And early on, there were lots of sort of um, attempts to commercialize it. Not totally not unsuccessful. Product was sold into footwear and safety boots and sofas. There was an attempt, work going on in automotive, but it was about 2010 that the company focused, quite rightly, they had to focus and commercialize something into aviation. Um, and although Chris had started out to solve a waste problem, the product was successful not because it was recycled. It was lighter weight, so it was a huge cost saving. It was more durable than a traditional leather, so it lasted longer. And because it's a consistent material on a roll, it's a lot easier to use than irregular leather hides, and those are triple win. And we've been incredibly successful in aviation. I think we have product and on flying on about 1 in 5 aircraft globally.
Hmm. So it's all
So
aviation upholstery.
Oh, aviation upholstery and also bus and coach and train, but transportation seating,
Mm,
lightweight flame retardant products. But really, this new factory was not built to make products for that market. It was built to move into newer markets, larger markets, all part of the growth of the company. So it was built to make footwear, and leather goods. Um, and so, yes, we're just commissioning this factory at the back end of 2019, going into 2020, and then COVID happens. Um, and you can imagine the effect of that on a company that most of our business is in mass transportation that just almost stops overnight.
mm. It must
Um,
have been quite a shock to the system. I mean, it was for
it was,
everyone, but
it was, and a lot of businesses suffered, but I think businesses that were involved in mass transportation probably suffered more than many. And so the story, I'd joined to lead the product development programs, and so that really became the survival mechanism for the company. Is speed up the diversification. We didn't know how fast aviation was going to come back. Actually, it bounced back a lot faster than it expected, and we're back at pre-COVID levels. But it
mm.
really was, we've got this new factory, we need to get it running. We need to get products into the market with, in footwear and leather goods. And so that story of the last 5 years really has been about how we have done that and how we have been successful. So we now have product on Dr. Martens boots. We have product on Coach handbags. And so,
It would be interesting to hear a little bit about that process if you're able to share it. How
yeah.
because it seems almost quite glib to say, oh, well, we better diversify. You don't just wave a magic wand.
No, I mean, it was quite a journey, and
Mm.
quite a journey, and obviously, technically, leather or material for a boot has to perform very differently than for an aviation seat.
But
Uh,
those three points that you mentioned, the consistency, the durability, and what was it, lighter? That was the other thing.
yes.
Those 3 points, they surely still stand for all leather goods.
They so some of it does, and
Mm.
and whatever product we're making for whichever market, it's a common manufacturing process. And for somebody technically and interested in manufacturing, I find it fascinating how we change the process to make the output product very different and very, very suitable for different markets. And with it being a composite, I always think of it being somewhat of a modular product. There are a number of different components in there, and we can change one component to change, for example, tear resistance or flame retardancy. And so I think, coming back to why I was, originally decided to be a chemist rather than a biologist, it's a toolkit, and we have a toolkit here. We can put things together in a different way to make very different products. So yes, the strength, durability is important whichever market we go across, as well as the fact it's a roll-to-roll process. It's efficient. You get rolls of consistent material out rather than animal hides that are a regular shape. But whereas aviation seating, you want a lightweight product, a boot such as a Dr. Martens boot, you want a much thicker, stiffer product. And the fascinating bit is how you change the process to do that. And then again, you go into a luxury handbag. Well, you don't want it to be thick and stiff. You want it to feel luxury. And this is one of the differences between the various markets. In aviation, you've got a very clear specification. You've got strength, you've got abrasion tests, you've got fire tests to meet, and to a technical person, you can understand it. You then sit with a designer of Coach handbags, and they're feeling the product, and they're using words we barely understand to start with. It's buttery, it's full of body, and so we've got the last few years we've gone through this process of learning this. To start with, you have to calibrate your hands, and to start with, we're touching two different materials that they say are completely different, and that can't feel any difference. And over time, yes, we can now recognize those differences. So big learning curve there. But I think that comes into one of the reasons we've been successful is that the partners we have worked with, so Dr. Martens on the footwear side, and Tapestry, who the company who own the Coach and the Kate Spade and the Stuart Weitzman brands, we've had a very good relationship with them. So we've sat down, we've looked at samples together. We've been into the factories where they make these products and worked together to make it work. And I think for anybody introducing alternative materials into an existing supply chain, that partnership for the first development you do is absolutely critical. There are other examples I could give where we haven't had that strength of relationship, and it hasn't worked out, because you can miss what's important. So what gets written on a specification sheet is not the full story about what the product needs to do to work. So what we have learned over the last few years about what is successful, there are really three things, and the focus has shifted from transportation seating. It was all about performance and weight and cost saving. And weight saving on an aircraft is a huge sustainability benefit, so it's a great thing to do. But the interest we are getting now from the partners we are working with is far more about the sustainability. That is what they are interested in. That is where they want to turn the dial. So there are three things we need to achieve. We need to be better on the sustainability side than the material we are displacing. And we're looking at about 80% savings in terms of carbon dioxide emissions compared to a traditional leather. Now, we leave it to the brands to make these claims because they know what they are changing. They know the materials they're making at the moment. So we would never give an absolute figure on what the carbon dioxide saving is. We would work very closely with them. We will do a life cycle analysis. We will share with them all the assumptions we have made. And then when they make a claim in the marketplace, they will audit it and they will make sure that they are comparing apples with apples. But that's coming down to it's trust in that relationship. It's a little bit unnatural for somebody who's worked in manufacturing for a long time to tell a customer exactly what the formulation is. That takes a leap of faith, and we have to recognize they're not going to run off and start recycling leather. We can share the information with them. They are responsible. They are asking these questions for a very good reason, and that's the strength of the partnership. So you have to meet that environment, that planet part of it. It needs to meet the performance. So people are not going to compromise on performance. There are a lot of alternative materials there that are interesting but don't have the performance, and they are never going to be adopted at scale because of that. The end user who is wearing a boot is not going to accept poorer performance than they have at the moment. So you have to meet that performance. It needs to be at least as good as what it is displacing. And then finally, it's the price. Do we need to do it at the right price? Because it's only going to scale if we get the price right. And it only makes a real difference to the world and the environment if we do this at scale. And so those are the three things that come together that has made us successful in these new applications.
Planet, performance, and price.
Yes, yeah.
I just coming back to that the planet point, how do you keep, I mean, we haven't got much time left, so maybe this is the worst question to ask, but I'm just intrigued to know how you keep production sustainable in terms of the planet when it comes to recycling the leather? Because obviously it's good that we can use a waste product, but
Mm.
the input into recycling most things, as we know, is can be counterproductive. So it would be really interesting to know some of the steps maybe that you take in the manufacturing process to keep that process sustainable.
Yeah, so it's interesting because I'd done some work on recycling before, and you can do it technically, but it doesn't necessarily make sense price wise or even environmentally because the amount of energy that gets used. I think one of the things is that we are physically untangling fiber together, so we're not bonding it together with adhesives or anything. So we and we this is a journey. There's improvements we can make. We try to limit the amount of fossil-based chemicals we use in the manufacture. We try to rely on the natural fiber, the properties of the fiber, and physically untangling it.
Mm.
But there are other things. Certainly, energy usage is one, but also water usage. So we're using high-pressure water to untangle it. We recycle that water. So we have our own water treatment plant that strips out any leather waste that ends up in the water. So it's complete closed loop on the water.
How long does
Because
that
a lot of it,
last?
how long does it last? Um, I, I don't know how many times the water goes around. It is very rare that we would change the water. There's about 200 tons in the system.
Mm.
So there's a huge amount of water there. Um, and our cleanup of the water is sufficiently efficient that we strip out any of the solids and the water continues to work for that entanglement process.
Mm.
Um,
Mm. I mean, there are so many areas that we can cover, but we are getting to the end now, and I just before we go, just wondered if you could share with us what your hopes are for the future of science, and it could be from any angle really, even back to
yeah.
where you
Um,
started.
I think what struck me is I think when I embarked in chemistry, I didn't know where I was going to go, and it's probably like 10 years into my career that I end up in a manufacturing plant and discover, yes, I love this manufacturing. This is fascinating. This is what I want to do. But also, since then, there's a lot of skills I have learned. Some of the Six Sigma skills, design of experiments, some of these things that I have learned, and I've really wished I'd learned that earlier on. So I think there is something about um, education in science and how it needs to evolve to still be relevant for how scientists work in industry, but also to get them interested in the bit that they might want to go on and actually do. How do you want to know you want to be a chemist in manufacturing if nobody ever talks about it? Chemistry, you talk very much about, A-level degree. It's synthesis of a pure material. That's what you're chasing all the time. The practicals are what's the purity of your material. And then you get into industry, and actually a lot of it is about how you mix different chemicals together to get a particular effect. But the other thing I've learned in a lot of the manufacturing processes that I've worked on is that you're looking at the end performance and what is important to the customer. Maybe 50% of that comes from the chemistry and the formulation. The other, at least 50%, comes from the manufacturing process and some of the details of how you do it. And I don't know of any sort of scientific discipline that pulls all of that together, the chemistry of the materials and the manufacturing processes. I don't think it doesn't always sit in even material science or chemical engineering. And I think there's something there about a slightly more holistic view of education and how do we prepare people for what they might be doing in the workplace. But also the world is changing, and one of my interests is, and I'm not sure artificial intelligence is a good term for it, but it's these new emerging technologies of being able to process huge amounts of data. That's really useful to us.
Hmm.
How do we use it, and how do we train people to use it? So,
We
you
could
hear
almost
about
change the name of it. We could call it artificial assistance.
it could be, and before it was called artificial intelligence, a lot of it was called machine learning, and you know, I think there are better terms for it, but you know, rather than discouraging students from using AI to write essays, we should be teaching them how to do it and the
Hmm.
right way to use AI, not for the creative bit. It needs to be clear what the human input is, but in terms of doing that research and understanding what is out there, I think we need to be using these techniques better. One thing that really interests me is using these techniques to understand the patent literature, because there are so many patents out there, and I'm never going to read them all.
No.
And yet, a lot of the answers to some of the hard questions we have are probably there. And as a society and as an industry, we really need to make better materials for the future, to do what Chris Bevan did, and look at a pile of waste and say, I'm going to sort that out. That's wrong. Um, and maybe there are new techniques that help us to do that faster and to do it better. But there's a right use of those things, and there's a wrong use because they're consuming energy themselves. So I think there's something there in working out how we train the next generation of scientists to do things better.
Hmm. And having AI being part of that.
I think it's not going to go away, is it? It's not, some people love it, some people hate it. Um, I flip between the two depending on the day and the subject, but we should be learning to get the best out of it.
Hmm. Another tool at our disposal.
Exactly, and um, we need to make we need to make better materials faster than we are, and maybe this is a tool that helps us do that.
Hmm. Quite possibly. Fingers crossed.
Yeah,
Well, Richard, I think that brings us to around about the end. So thank you so much for your time. Really interesting insight. I can't wait to see a bag made out of the composite leather from Jen Phoenix. And yeah, long may that continue.
great. Thank you very much.
Did you enjoy that episode of Lab Matters? If you did, please do send it to the people that you think will enjoy it the most.